Hello, good morning, dear students. This is Tukaram Munde from Department of Chemistry, Sanjeevani College, Sapoli. Hope all of you may be good and studying hardly for your next semester examinations. Today we are going to see the syllabus for BSCSY subject chemistry and paper number 7th, which is a physical and inorganic chemistry paper. Our paper includes two parts. One is physical chemistry part and another is inorganic chemistry part. Physical chemistry part constitutes 4 units, while inorganic chemistry part constitutes just 1 unit. In physical chemistry, in previous class we have seen the structure of atom in general. Now in this year we are going to see structure of atom according to wave mechanics. It means in BSc first year you have learned about classical theory of structure of atom, and now we are going for the wave mechanical theories or quantum theories of atomic structure. In this atomic structure, which is first unit, we are going to see Planck's quantum theory, photoelectric effect, Compton effect, then de Broglie hypothesis, Davison-Germer experiment, and after that we are looking for Heisenberg's uncertainty principle, Schrodinger wave equation, that is time dependent form, then the problems based on the photoelectric effect, de Broglie hypothesis, and Heisenberg's uncertainty principle. All these are included in our syllabus. This is to understand the wave nature of a atom. Wave nature of a atom. And by studying all these theories, we come at a point where we may be known about the wave mechanical structure of the atom. This is a very good topic for your post graduation and other competitive examinations. Then the second topic is, or the second unit is, thermodynamics. Now you know thermo means heat and dynamic means changes or kinetics. In previous years you have learned some concepts of the thermodynamics, such as what is noise system, surrounding, boundary, types of systems, then first law, second law, third law. All those things were to be learned by you in the previous years. In this year we are going little bit deeper, and firstly there is just or review of first law of thermodynamics, that is introduction to the first law of thermodynamics, and after that the applications of or the principles of thermodynamics, that is Joule's law, then Joule-Thomson effect, Joule-Thomson coefficient. After that, the need of second law and different statements of second law of thermodynamics. After all this, the thermodynamics includes Carnot cycle, which is a very important topic. Carnot cycle. In this, we are going to determine the efficiency of a thermodynamic process and to see Carnot's theorem. After the completion of second unit, we are going for the concept of entropy, which is also a part of thermodynamics. This is third unit. Then you know what is by entropy. You have learnt it in 12th standard. Entropy means nothing but it is randomness, just randomness or disorder. In concept of entropy, we will see the definition, mathematical expression, and some entropy changes that are occurring during physical transformations. It means how does entropy varies with change in physical state of a substance. For example, when a ice cube melt, then it forms water, that is liquid water. Now there is change in entropy, that is increase in the entropy. Then after this, when we boil the liquid water, at that time the water becomes vapor. There is also some positive change in entropy. All these changes, it could be either positive or negative, we will see in this topic. Then we will see the entropy changes for ideal gas as a function of volume and temperature, and as a function of pressure and temperature. It means one time we are keeping pressure constant and another time we are keeping volume constant. At that time we have to measure the changes in the entrophies. After that we will go for the physical significance of entropy and the problems based on the entropy. After the successful completion of the concepts of entropy, that is third unit, we are going to fourth unit, that is phase equilibria. Meanwhile, learning all these things, we will conduct internal examinations, some seminars, and group discussions. All those will be conducted during the semester. So the next, that is fourth unit, is phase equilibria. Then in this concept we will see what is meant by phase, and there is a rule called phase rule that governs the mixing of two phases or the system of two phases. And there are some terms by using which we can determine some of its properties or quantities such as phase, component, and degree of freedom. Then we will see one by one phase equilibria of various components, that is one component system, two component system, three component system, all those. The first system is water system, which is a one component system. Also after that we will see sulfur component system, then CO2 system. After that we will see the two component systems such as lead silver system, uh, KIH2O system, and decellularization of lead, all these. After this we will see some properties of partially miscible liquids, that is critical solution temperature, upper critical solution temperature, lower critical solution temperature, and some phase equilibria such as phenol water system, triethylamine water system, nicotine water system. All those systems can be studied in the phase equilibria. And the last point of this unit is effect of impurities on critical solution temperature. It means how does critical solution temperature varies with addition of impurities in the solution. In this manner we will complete the physical chemistry topic or physical chemistry part. The second part is inorganic chemistry, and it includes two units. One is nuclear chemistry and another subunit is theory of gravimetric analysis. Inorganic chemistry has just one unit, but it has been divided into two subunits. So the first unit is nuclear chemistry, which is very important for those students who want to work in the field of nuclear chemistry or nuclear physics. Those who want to become a nuclear scientist, they must go thoroughly through this topic. So this topic constitutes introduction. What is meant by nuclear chemistry? What is meant by nuclear chemistry? Then what is the composition of nucleus and nuclear size? Then we will see different nuclides and their classification, and these are isotopes, isobars, isotones, and isomers. After this we will see nuclear stability of the nucleus. How does odd and even number of protons and neutrons or n by z ratio makes difference in the stability of nucleus. As n by p ratio increases, the nuclear stability decreases. As n by p ratio decreases, nuclear stability also increases. After that we will see magic numbers, packing fractions, and the problem based on the magic numbers, packing fractions, and mass defect. After this we will see mean nuclear binding energy. It means the energy that is required to break a nucleus into its constituent particles. Then there is release of nuclear energy, that is the release of nuclear energy occurs by the two processes, that is nuclear fission and nuclear fusion. For nuclear fission, which are the nuclear fuels and what is plutonium bomb? And in case of nuclear fusion, we will see the energy of sun, hydrogen bomb. It means there are two processes that of nuclear reactions, one is fusion and another is fission. Fission means split up and fusion means to combine. On the sun, the nuclear fusion reactions of hydrogen occurs to form helium. And in the nuclear reactors, the nuclear fission reactions occur to provide energy to us. The nuclear reactors or the nuclear power stations in India are Tarapur, Kudankulam, Kakrapar, all these. After nuclear reactions, we will go for the radioactivity. There are many substances in this universe that radiates energy, and this process of emitting energy from a substance is known as radioactivity. There are some elements that are radioactive such as uranium, plutonium, and all the transuranic elements are radioactive. They emits alpha, beta, gamma particles in the form of energy. So, we will see what is meant by radioactivity, what are the characteristics of alpha, beta and gamma particles, and after that we will see the group displacement law and applications of radioisotopes in medicine, agriculture, industry and carbon dating. In medicine, we use iodine for goiter or iodine 35 for other purposes. Then we will also see use cobalt and other radioactive elements for various purposes. In agriculture, we use radioactive materials or radioactive particles to store the agricultural products. Then in industry such as power generation, we use radioactive elements, and also we use carbon 14 for carbon dating, which is used to know the age of fossils. After looking all the importance of this nuclear chemistry, we are going for the theory of gravimetric analysis. You have learnt in the BSc first year the basics of inorganic chemistry, and now we are going little bit deeper. In second unit of inorganic chemistry, the topic is theory of gravimetric analysis. Gravimetric means weight based, and in this topic we will see the analysis of various inorganic compounds or ions based on their weights. In this topic we will see introduction, definition of gravimetric analysis and steps involved in gravimetric analysis. And there are some steps, that is precipitation, solubility, digestion, filtration, washing, drying, ignition, incineration, and weighing. All these are the steps that are involved in the gravimetric analysis. Then we will see conditions of precipitation and factors affecting precipitation. All this could be learnt in the third semester of your BSc SY. After looking all the syllabus, I will provide you syllabus notes and questions, university question papers. In addition to this, I will suggest you some names of the books for your further study, and these are Physical Chemistry by Barrow, McGraw-Hill publication, then Elements of Physical Chemistry by S. Gladstone and D. Lewis, then next is University General Chemistry by C.N.R. Rao, Macmillan publication, then Elements of Physical Chemistry by P.W. Atkins, Physical Chemistry through Problems by S.K. Dogra and D. Dogra, and the next one is very important, Principles of Physical Chemistry by Puri Sharma Pathania, Vishal publication, Jalandhar. This is a very important book. Also, Atkins book is very good. The next is Essentials of Physical Chemistry by Arun Bahal and Tuli. The next is Advanced Physical Chemistry by Gurdeep Raj, Goel Publishing House. The next is Principles of Inorganic Chemistry by Puri Sharma Kalia. Advanced Inorganic Chemistry by Gurdeep Raj and Chatwal Anand. Advanced Inorganic Chemistry Volume 2 by Satya Prakash Tuli, Basu and Madan. Inorganic Chemistry by Hui, Kitter and Kitter. Nuclear Chemistry by Arnikar and Concise Inorganic Chemistry by J. D. Lee. For your inorganic topic, that is gravimetric analysis topic, you will see Vogel's Qualitative Inorganic Analysis, 7th edition. Vogel's Qualitative Inorganic Analysis, 7th edition. Then the next is a textbook of Practical Chemistry for BSc by Nadkarni, Kothare, Lawande. And then Inorganic Chemistry by Shah. All those books are available in our laboratory, college laboratory library. You may ask for those books to our librarian and go through it. I give my best wishes for your semester examinations and for this new academic year. Thank you.